Factor completely. Since this 100 is a perfect square, there's a minus in between, that's a perfect square. That goes to the two sets of conjugates. Square root of 100 is 10, so 10 and 10. And then a squared, b squared, square root would be just ab. Since it's a difference of squares, they're conjugates. 1 plus, 1 minus. That's factored. The same pattern for this one, perfect square, so it goes to two parentheses that are conjugates. It goes to x squared, and then plus 4 and minus 4 for square roots. But there's one more. These are both still perfect squares. So x squared minus 4 goes further. X plus 2, x minus 2. Same pattern. X squared plus 4, that's it because it's a plus. You can only factor when it's minus squares. For this one with parentheses, some people can do it with parentheses, some people need a little trick. Here's the little trick. Take away the parentheses and put a u instead. And then factor. So we're just replacing parentheses with a u in both cases. Factor, we can take out a u squared. And then we still have the 3 and a u minus 5 because we took out u squared. And then to undo our trick, we just put the x plus 2 wherever there was a u. X plus 2 squared, 3, x plus 2, minus 5. But now we have this second parenthesis here. This can be simplified if we distribute. We get 3x plus 6 minus 5. So we can rewrite this as x plus 2 squared. And then 3x plus 1 Here we have 121, which is 11 squared, and then parentheses squared. Two ways to do it. We could do that u substitution again. You can say that's u squared. Or maybe you could go about it without doing that. It's not that more complicated. So the 121, since these are both perfect squares and there's a minus, we can split it up to 11 and u. And then since it was a difference of squares, they're supposed to be conjugates, so 1 plus, 1 minus. But that u is supposed to be x plus 1. So this should be 11 plus x plus 1. And 11 minus, parentheses, x plus 1. Some people are perfectly fine and able to just jump from the original problem down to green here. If you see that. But now we have this minus plus parentheses doesn't mean anything, so those parentheses inside don't matter. But when we combine the 11 and the 1, we get x plus 12. Here you have to distribute the negative. So that's minus x minus 1, which you could either write as negative x plus 10, or you could have said 10 minus x. Doesn't matter. They're both right. 10 minus x, x plus 12. Either answer is good. You may have just stopped right there, or you could have switched it around. When you're factoring in, there's 4 terms. That's always going to hint that you're going to factor by grouping. So split it down the middle, take out the common factor from each half that we split it into. X to the 4th, x third, we can take out x to the 3rd. And then plus 3x minus 6, we can take out a 3. We have x minus 2. The trick for grouping is that the parentheses have to match, and that's part of your final factor. And then the front parts that you factored out, x cubed plus 3, that's the other parenthesis. If it would factor further, that's what you would do. But we have x cubed, and 3 is not a perfect cube, so it does not factor anymore. If that was a different number like 8 or 64 or 27, it would factor more. Here's an example of those cubes like we were just talking about. 54 and 128. First thing you need to do is take out a GCF of 2. They're both even. Divide them by 2. Now we have perfect cubes. 27 is a perfect cube. 64 is a perfect cube. So when we factor that, it goes to the smaller parenthesis and the larger parenthesis. That 2 that we have factored out stays in front. The trick for cubes, my acronyms that I use are SMS. So first we just take the cube root. 27 goes to 3x. 64, the cube root is 4. I'll fill that in a second. SMS means you take these two numbers, first you square 3x. So 3x times 3x is 9x squared. M means multiply. 3x times 4 is 12x. And the last S, that means square again. We're squaring the 4 this time. 16. And then the second acronym that I use for this is SOAP. Same, opposite, always positive. That tells you how to fill in these 3 blanks. You fill it in with the same sign, the opposite sign, and then the last one's always positive. Again, always start with a GCF. So 11 and x can be factored out, 11x. In the front, we'd get an x squared left over, minus 11x divided by 11x is 1. Now we have 2 terms. X squared is a perfect square, 1's a perfect square, so that's going to our 2 parentheses. It's minus in the middle, so they're conjugates. X plus 1, x minus 1, with 11x in the front. Again, we have parentheses. I would change those to U's to make this a little bit easier. So now we have clearly a trinomial, which we're going to factor to be 2 parentheses. There's no leading coefficient, so the numbers that we're going to fill in have to multiply to be negative 30 and add to be positive 1. That's 6 and 5. Positive 1 would be a positive 6 and a negative 5, and that gets you negative 30 and positive 1. The middle fraction, or not middle fraction, the middle variable part, u to the 1/3, goes in the front. Since there's no leading coefficient, that's it. But we did that u trick where we changed parentheses to U's. So now we need to change our U's back to parentheses. Or maybe you didn't have to do that step at all, and you just knew that you could have jumped to this. Replace the U with x minus 2. That's it. Same type of factoring. We have a trinomial, so we're with no leading coefficient. So we go to our two parentheses. The middle variable piece goes in the front. The first variable just has to be double. The exponent has to be double. It is. And then to get 20 by multiplying, and it has to add to be -9. So that's 5 and 4. -5, -4. Then we have to be a little bit more careful and notice that these are x to the -2nd. That's still a perfect square. 5 is not a perfect square, so that one's done because 5 is not a perfect square. X to the -2nd, that's a perfect square. 4 is also a perfect square, so we're going to split it into conjugates. Square root of x to the -2nd will be x to the -1st. Square root of 4 is 2. And they're conjugates, one time with a plus, one time with a minus. And that's factored all the way. If it says factor completely, make sure you do factor completely. Four terms again, that's grouping. Split it down the middle, take out a common factor. X squared we can take out a -9. 2x plus 1. Your parentheses match, that's part of our factor. And then the front parts that we factored out, x squared minus 9, that's the other. And again, x squared minus 9, those are perfect squares. So you need to pay attention whenever you see perfect squares, you factor further. X squared goes to x and x. 9 would be 3 and 3. Since it's a difference of squares, they were conjugates. And 2x plus 1. Again, that's factoring completely. You got to be careful that you check after you factor, does anything else factor? Indicated operation. So in this case, we are subtracting fractions. Adding or subtracting fractions, you need a common denominator. We've talked about how these are very similar. X minus 3. And when we look at 3 minus x, we can actually think of 3 minus x and the x minus 3. The only thing that changed is the signs. The x went to a negative x, the 3 went to a -3 to a positive 3. You can rewrite it, factor out a negative, and it changes to x minus 3. So the only difference between these two denominators is this negative. So let's take this denominator, let's factor out that negative. And in a fraction, it doesn't matter if the negative is part of the denominator, part of the numerator, or if you pull it to the front. So this negative, currently part of the denominator, you can put it with the numerator or pull it to the front. It doesn't really matter. So let's take it, I'm going to pull it up to the numerator instead. And now we see they do have common denominators, x minus 3, which means you just do the math with the numerator. 8 minus negative 4. 8 plus 4 is 12. If anything factors, you factor and cancel, but nothing does. So that's it. Here's another one. We need common denominators. It's not as simple because these aren't even close. So instead, we need to get a common denominator by multiplying basically by each other. The common denominator is going to be x minus 2 times x plus 3. So x minus 2, the part that's missing from this is the x plus 3. Multiply it to numerator and denominator. And on our second fraction, the part that's missing is the x minus 2. Multiply it to both numerator and denominator to get our common denominator. So from the left part here, we have 6 times x plus 3. We can distribute that. 6x plus 18. From the second piece of this, we have negative x being distributed, because it's negative x times x minus 2. So negative x squared plus 2x, negative times negative. By like terms, for the numerator, we have a negative x squared, 8x plus 18. Since this starts with a negative, sometimes you will see it get factored out from the numerator. Change that to positive x squared, negative 8x, negative 9. And the main reason to do that is to check to see if the numerator factors. If anything multiplies to be negative 9 and adds to be negative 8, it does. We could do 9 and 1. It would be a negative 9 and a positive 1. For the numerator, our denominator was x minus 2, x plus 3. And since none of these match, nothing cancels out. That's as simplified as it gets. Multiplying fractions, you really just want to factor everything. So factor x squared minus x minus 6. Multiply to be 6. Add to be 1. That's 2 and 3. Since it is negative, we need a negative 3 and a positive 2. For our denominator, multiply to be 8. Add to be 2, that's 4 and 2. We get a positive 2, it's positive 4 and negative 2. Multiply to be 16, add to be 8, that's 4 and 4. Both positive. And then our denominator here just has a common factor of 3, x plus 4. Now you go through and cancel anything in the numerators. X plus 4, x plus 4, x plus 4, x plus 4. As long as it has a match in the denominator, it cancels out. Plus 2 minus 2, that does not cancel out, so we are left with x plus 2, x minus 3 over 3 times x minus 2. Dividing fractions, I remember it as keep, change, flip. So we keep the first fraction, we change divide to multiply, and we flip the second fraction. So as we do that, we will factor, take out a 5z from the numerator, 2z minus 1. From our denominator, we can take out a 3z squared, and we're left with a z minus 2. Changing it to multiplication and flipping this. So z squared plus z minus 6, that goes up top. Multiply by 6, add to be 1, that's going to be 2 and 3. To get a positive 1 is positive 3 minus 2. And then our denominator has a 2 in the front, a leading coefficient of 2, so it's not as simple as what we just did. I always multiply, follow this trick here, multiply the front to the back to get 6, negative 6. This is called splitting the middle, so we're going to rewrite 5, the positive 5, as the factors of negative 6. So that'd be a positive 6 and a negative 1. But since that was 5z, we're going to write it positive 6z minus 1z. The 2z squared starts our polynomial stays, then the minus 3 at the end. So all we did is we took that positive 5z and we split it up as 6z minus 1. When we do that, so we can do factor by grouping. Take out a 2z, you're left with z plus 3. Take out a negative 1, we're left with z plus 3. So factor by grouping worked on this now. We get z plus 3 and 2z minus 1. So remember, that was our denominator here. Our numerator had z minus 2 and z plus 3. And our other fraction was 5z times 2z minus 1 and 3z squared times z minus 2. But now we can cancel to reduce this. 2z minus 1 cancels 2z minus 1. Z plus 3, z plus 3. Z minus 2, z minus 2. A whole lot of stuff canceling. So all that we're left with is 5z over 3z squared. We can also reduce the z on top. We'll cancel one of the z's in the denominator. So we are left with a 5 in the numerator, and that's it. And then a 3z in the denominator. So that simplified a whole lot. Complex fractions, we look at each piece as a fraction. So this is x over 1. And this will be 1 over 1. We look at each fraction, each denominator. We get a common denominator, x1, x1. The common denominator is just x. We're going to multiply the common denominator of x to each fraction here. So we're going to multiply it to the top left fraction, the top right, the bottom right, and the bottom left. Since we're multiplying Here we get x times 9 over x. These x's are going to cancel out. That's going to be the fastest way to handle that. We get 9 minus x times x is x squared. Since the denominator was 1, nothing canceled. X times 1 is x. Here these x's cancel out again. So it's just plus 3. 9 minus x squared, that is a difference of squares. Perfect square, perfect square. So that factors. Now the square root of 9 is 3. And it's the conjugates because it's perfect square. So 3 minus x, 3 plus x over x plus 3. Well, addition, it doesn't matter the way it's written. 3 plus x or x plus 3, those are the same thing, so they cancel out. Subtraction, it matters, but division, or addition, it does not. So they cancel out. We're left with 3 minus x. It's the only part left. That's your final answer. Same idea on this problem. Think of everything as a fraction. Common denominator between 1, 1, x, and 4 is 4x. So we're going to multiply 4x to each fraction. You can reduce before you multiply. So here the 4's cancel. We just get x times 1. Here the x's cancel. So that's 1 times 4 is 4. In the denominator, that's 16x, because nothing cancels since it's over 1. And then minus 4x squared. But that factors x minus 4. We can factor out a 4 and an x, and we write it instead as 4 minus 4x. We took out 4x squared, took out 4x, that's minus x. And like we hinted at before, on that last problem, x minus 4, 4 minus x, they're almost the same, but order matters with subtraction. But you can switch the order if you factor out a negative. So you could rewrite that as negative 4 minus x. Multiply that back, you got negative 4 plus x, which is the same thing. So really you're just factoring out a negative from the top, which now 4 minus x, that cancels. So our final answer here is negative 1 over 4x. Once everything simplifies, cancels out.